Looks like we'll just do a bunch of everything then. All right, what year was this? This was the 2008 HSC. We'll do, we'll start from the top. Start from A. I guess I'll get started first, nice and early in the morning, and then I'll get you guys working on a similar question. So turkey is taken from the refrigerator. Its temperature is 5 degrees Celsius. When it is placed in an oven preheated to 190, its temperature after 2 hours in the oven satisfies this equation. Show that this satisfies both this equation and the initial condition. Both this equation and the initial condition. Okay, so of course, for this equation, what do we usually do to satisfy the equation? Differentiate. So we're going to differentiate the derivative of 190 with respect to time is 0. The derivative of an exponential is still the whole exponential, so it's still negative 185 e negative kt multiplied by the derivative of the power, which is negative k. Negative and a negative makes it into a positive, but pause. Because you're proving something, what's happening? Hold on, my pen seems to be frozen and my mouse is working. The program's stuffed up. I'm stuck. I am stuck. I can't even exit the screen. Oh, there we go. We're back. Wait. Yep, it just crashed. Perfect. All right. And we'll go again. (2008) wasn't it? 2008. All right. So like I said, dt on dt is equal to negative 185 e negative kt times negative k. I was going to say, yeah, let's multiply them. That's what we usually do. But I said pause. Look at always what you're trying to prove. Can you see it says negative k bracket t minus 190? That means you want the negative k. So you wouldn't actually multiply it in and make it into a positive. If you want a negative, leave the negative as it is. Then what is negative 185 e negative kt? What is negative 185 e negative kt? What isn't it t minus 190? See how easy that was? Which is, so I just rewrote the answer. Differentiated and then rewrote the answer. I didn't bother simplifying. That's probably the smartest way to do it. Any questions? That satisfies this equation and the initial condition. So what are you meant to do for initial conditions? T equals to 0. And what should it be when t equals to 0? When time is 0, what should the temperature be?
5.
5. Because its temperature is 5 degrees Celsius. Right? So let's see if it's true. T equals 190 minus 185 e to the 0. E to the 0 is 1. 190 take away 185 is 5. True. I mean, you would write, therefore, satisfies initial condition. Or if you just did it the way I did it and put a tick, we'll also give you 4 marks. Easy. Next one. The turkey, double A. The turkey is placed into the oven at 9 a.m. At 10 a.m., the turkey, so that's the starting point. That's when time is 0. At 10 a.m., the turkey reaches a temperature of 29. That means when time is 1 hour. Turkey reaches a temperature of 29. T is 29. The turkey will be cooked when it reaches a temperature of 80. When the temperature is 80. At what time will it be cooked? Okay, so of course, you're going to sub. You always need to find K first. So you're going to sub in your first set of conditions, which is when time is 1, temperature is 29. so double I. Time is 1, temperature is 29. Temperature is 29 equals 190 minus 185 E negative 1K, so just K. We should know how to solve for K by now. Subtract 190, divide by negative 185, log both sides. You'll have negative K, and then you'll divide by negative 1. I actually do it like that because I believe you guys need to be at that level. So you got to just see, to solve for K, subtract, divide by negative, log it, divide by negative 1. The answer, if we plug this into our calculator, is 29, take away 190, divide by negative 185, log answer, divide by negative 1, K equals 0.139. I'm going to store that on my calculator. Question says, at what time will it be cooked? When the temperature is 80. So now we know your new formula is, T80 equals 190 minus 185 E negative K 0.139 T. And you're going to solve for T now. The only difference is my K value is not this. It's the whole exact answer that I have in my calculator. That's the only difference. So, but here we go. This is how you would solve for T. 80, take away 190. You'll divide by negative 185. Then you're left with the E. You would log both sides. You'll be left with this number. You'll divide by that whole thing. All right. Log 80 minus 190 on negative 185 divided by negative. Did I store it? Yes, it's stored. Start again. 80, take away 190 on negative 185, log answer, divide by negative alpha A, 3.7, 4, blah, blah, blah. The students who wrote that got 2 out of 3. What's the answer that we're looking for? What's the answer that we are looking for?
Need to put in degrees and minutes.
So this one becomes this. 3 degrees, I guess 44 minutes. If you've used the exact answer. If you didn't, maybe it might have been a bit over, it might have been the same, I'm not sure. You still would not get full marks. It's still 2 out of 3.
You need to put it as time, so 10 a.m. plus 3 hours.
Ooh, which one? 9 or 10? 9 a.m. or 10 a.m.? You said them both.
10 a.m.
Wrong. It starts from 9. Why did you start it from 10? That's just another condition. Yes, to get full marks, the question actually says at what time will it be cooked? Not how long. This is how long it takes. Time would be 9 plus 3, what's that, 12? 12, 44 p.m. That would be full marks. If you did not write that, yes, you will not get full marks. If you rounded by accident, let's see, if I use 0.139, just again, as always, for our own curiosity, let's see if it would have worked. Divide negative 0.139. Yep, it would have worked for this question, so it wouldn't have made a big difference if you had used the exact or not. That's cool. But yeah, time. At what time? For your own curiosity, I mean, for all of you guys, I mean, you're doing it very mathematically, but just so you know, the high-end restaurants, I know one particular chef, I'm not sure if you've heard of him, he's a very famous chef who uses a lot of science and math, Heston Blumenthal, who actually they use obviously all of this math to make sure every, let's say, chicken, steak, whatever it is, it's always perfect every single time. Because that's what you're talking about. You're talking about the turkey will be, maybe this is cooked, but what if you want the turkey to be perfectly cooked? And math calculus allows it to do that. And we're going to learn more of that once we actually jump into applications of calculus in year 12. But just so you know, I mean, this is a very basic example, but this example is right. You do actually, they do actually use this in the real world. So just so here for you guys, but I mean, not your everyday restaurant. We're talking about the high-end ones, the ones that are looking for perfection, Michelin stars. They'll be using a lot of math to make sure everything is consistent every single time. Anyways, any questions about this stuff? No, 100% will be in your exam. If you've got rates of change, you know this will be guaranteed 5 marks. The working out's going to always be the same as well. You're going to be substituting your first condition, then your second set of conditions, and then solving it. And it's always worth 3 marks. They in advanced, they'll break it up, I, double I, triple I. In extension 1, it's just a 3 mark. You have to know what to do yourself the whole way through. So the good news is, if you know your extension 1, your advanced one that doesn't have this term, it's just this and this, will be very, very easy. Okay, part B. Barbara and John and 6 other people go through a doorway at one at a time. In how many ways can the 8 people go through the doorway if John goes through the doorway after Barbara with no one in between? All right, someone give me an answer.
5 factorial.
We got an answer of 5 factorial. Let's see what everybody else reckons as well. Anyone else have a different answer? Because I think I had a different one, unless I misread that. Let me read it again.
Wait, 7.
7 factorial.
Do you have the opportunity to change it in exam? Is someone going to tell you? You just got to realize. Maybe let's rub out the answer, just in case, just to be safe. Oh, what's happening? Oh, come on. Maybe it's my mouse. I'm going to switch this off. Okay, that's better. That's what was happening. Go back. Yes. All right. I had in how many ways can 8 people go through the doorway if John goes through the doorway after Barbara with no one in between? Well, my interpretation of that. Okay. 5, 7. What do you reckon? Anyone else have a different answer? Or we're happy with one of those? Does anyone actually understand what is happening and wants to say an answer? Well, the way I interpreted it was obviously, in how many ways can the 8 people go through the doorway if John goes through the doorway after Barbara? That means Barbara is definitely first. Or, it doesn't matter, Barbara's like, even if she's not first, if she's somewhere, 2, 3, 4, 5, 6, 7, 8, I just assume she was first. Then John goes after her, and no one in between. What is happening? This program's not responding very well today. It's on a weekend mode. J, John, and then of course there will be 7 factorial ways. That's the way I interpreted it. And it makes sense? 5, I don't know how we got 5 factorial. So, I don't know. Tim, you want to explain your answer of 5 factorial at first? What was the reason? Unless you just saw the 6.
Yeah, I just saw the 6.
Oh, come on. Barbara and John and. All right. Find the number of ways in which the 8 people can go through the doorway if John goes through the doorway after Barbara now. Find the number of ways in which the 8 people can go through the doorway if John goes through the doorway after Barbara. It doesn't matter who's in between and who's not. Okay. How are we going to do that? Again, any ideas? as long as John's just after Barbara. Well, again, you could have done B and J plus 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 B and J. You could do that all this amount of times. Or
Could you do it 1 minus probability of John before Barbara?
1 minus, don't forget, you guys, you can't, now that you've learned two things, be careful. Just be careful. 1 minus, you said probability, right? Now this is specifically for probability. We're doing number of ways. So when you want to use this concept, it's going to be total minus, I guess, opposite, let's call it. So be careful with that concept. It's still the same thing, it's just, I'm just saying don't look for 1 minus, because in your head you might be looking for 1 minus, but there's not going to be any probability. Find the number of ways in which 8 people can go through the doorway if John goes through the doorway after Barbara. So you're saying do it as John goes in before Barbara, which would almost be the same. Like, isn't there a lot of different combinations? So what would it be initially? Wouldn't it just be 8 factorial? Like if there was no condition, it would be 8 factorial, right? And if you're talking about one person going through the door after Barbara, so Barbara's here, and then John can be here, and then again, like I said, Barbara could be here, John could be here or here. So in fact, there's a lot of repetition. I don't know if you guys will get this one. Does anyone actually understand the idea of 8 factorial over 2? Let me see if I have to run through the case and maybe a few permutations. Let me think of a different way. Give me a second. 2008. Okay. Yeah, maybe I could have just done like that. All right. Or, let me just think of it another way. Find the number of ways in which 8 people can go through the doorway. John goes through the doorway after Barbara. It could be none in between, which we just said it was 7 factorial, but we just found in I. If I did 1 between, which would look like this. 1, 2, 3, 4, 5, 6, 7, 8. If there's 1 in between, then for example, let's just say like that, or B's there, J's there, or B's here, J's here. You guys get the idea? Let's just start from the beginning and then we'll multiply. So if I said 1 in between, so there and there, well, you've got 1, 2, 3, 4, 5, 6 factorial left. So 1 between would be 6 factorial times. How many ways can these B and J move? 1, 2, 3, 4, 5, 6. Because that's 1. Then the next one will be 2. Look, that's 1 way. Right? This would be the second way. This would be the third way. This would be the fourth way. This would be the fifth way. And then the sixth way. We understand that? Or, in other words, yeah, that's fine, times 6. So like, I hope you guys wouldn't have done it this way, but I'm just trying to show you, it should give us the same answer as this. The next one would be 2 between, right? So 2 between, if there was 2 between, again, this is B, 2 between, this is J. 2 between, we would have, how many times this guy's going to move? 1, 2 between. There has to be 2 between. So that would be, oh my god, this is going to be a killer.
It's 5 times.
It'll be 5.
5 times, no, it shouldn't be 5 times.
5 factorial.
Yeah, 5 factorial, because 6p4, you're going to put someone in there. Yeah, 5 factorial, right, times 1, 2, it's going to be 5 factorial times. Now, the fact that these guys can all move. That's one big group. 1, 2, 3, 4, 5. These guys can move. It becomes 2 times 3. Ah, hold on. It's just annoying this way, but then I was trying. I thought it would work out easier, but there's a lot. Like 1 between, 2 between, 3 between, 4 between, 5 between. Let me just work out 6 between for a second and think about what I'm doing. If it's 6 between, 1, 2, 3, 4, 5, 6. If this is B and this is J. Oh my God, no, don't do it this way. It's just going to be too annoying. But it has to give you the same answer. 100%. But hold on. It's just easier to do it this way. Find the number of ways, because it's only worth 1 mark. Find the number of ways in which the 8 people can go through the doorway if John goes through the doorway after Barbara. The way that would work should be, I don't want to do it this way. The number of ways 8 people can go through the door would be 8 factorial, but Barbara can walk through ahead of John only half of these times. Yeah, that's it. So find the number of ways in which 8 people can go through the doorway. I'm going to say Barbara is ahead, because to do the second way, you're going to be there all day for 1 mark, is ahead of John half the time. The other half, obviously, John is ahead. Right? If you guys understand that, the answer should just simply be 8 factorial over 2, whatever that gives in your calculator. It's a big number. And I'm sure I should be able to get the answers out for the other version, 2008. Let me see if I can get you, if we've got it right, it should give us the other method, which I really would have never done, but let's see. Give me a second. Does anyone actually understand this concept of dividing by 2? Because Barbara is ahead of John half of the time, and the other half, obviously, John's ahead. That's just simple symmetry properties. There's 8 people. Like if there was 2 people, either I'm going to be ahead, or like either John's going to be ahead, or Barbara's going to be ahead. If there was 4 people, again, half the time, John's going to be ahead, or Barbara's going to be ahead. If there's 6 people, again, half the time, Barbara's going to be ahead, John's going to be ahead. So that if there's 8 people, same concept, Barbara's going to be ahead. All right, do you guys get that? Can someone acknowledge that makes sense?
Yeah, that makes sense now. But what happens if it was like 7?
If it was 7, then you would have to run through the cases.
Mm.
If there were cases, that means 4 of them. No, it won't be half. Because if there was let's say again, if there was 3 people, well, that means one person will always be more ahead than the other at one instance. Right? So if there was 3 people, again, think of it. I mean, again, John could be ahead, Barbara could be behind, twice, I guess, and then the other one could be Barbara. Yeah. So it's +1, I think. But anyways, let's have a look if I can find you HSC solutions. It's HSC 2008 solutions and ascension. Let's see if these guys have it. Very slow today, the computer in the room. Really? Just the exam paper. Really?
Sam, there's solutions on THSC.
Oh, perfect. Yeah. Let's go there. Which is Year 12. Come on. Extension 1. THSC papers. 2000 and... It's still marking guidelines. Maybe it's in there.
Let's scroll down.
Oh, fair enough. Oh, I scroll down? Oh, yes. Good man. Well, I've just got this as well. Same thing. All right. I choose. Beautiful. Okay. Question 4. What was it? B. There's our turkey. Oh, they've done it my way as well. Okay, let's see if someone else has done it any other way. Again, Hanson's. Didn't work. Oh, there we go. Look, for 1 mark, you wouldn't run through the cases. That's the, maybe you're probably going to see all of these solutions from these guys done the same way, but we'll check it out anyways. Question 4. I would like someone to have done it. If not, I'll just run through the cases again later on and try and show it to you guys. Yeah, I thought so. These guys wouldn't. No, it wouldn't be done. It wouldn't be done slowly. I mean, it wouldn't be done, yeah, slowly. All right, that's all right. What can you do? You could have done the cases. I probably stuffed it up somewhere. So I'll do it again shortly. Once I get you guys working, I'll go back and try it. Let f of x equal to x minus 1 on x squared, 1 on 2x squared, sorry, for x being less than or equal to 1. Because if it wasn't, then it wouldn't be an inverse. It's a parabola, which we know does not have an inverse because it fails the horizontal line test. So the fact that it says x is less than or equal to 1 makes it an inverse. This function has an inverse. Sketch the graphs of the original and the inverse on the same set of axes. Use the same scale on both axes, please. Okay. So I. Well, I kind of wouldn't have done I straight away, I guess. Maybe because I would have liked to see what kind of expression the inverse would have been. But, you know, given that it's in this order right now, I might just do it. So what do we have? We've got f of x equal to x minus half x squared. We know if you factorize x out, we're left with 1 minus half x. Your x-intercept, you let y equal to 0. So you'll get x equals to 0 and x equals to 1 divided times 2 is 2. If we're not wrong. So that's when y equals to 0, y equals to 0. Okay, so our intercepts are at 0 and at 2, and that's why they gave you this half of that. Half of 2 and 0 is at 1. So the original curve was like this. You need to know what the y value is when x is 1. So when x is 1, y equals 1 take away a half is a half. Wait, whoa. 1 take away a half. Oh, very bad. It's negative x squared. You see how, thank God that allowed me to check that. Negative x squared, we know it's sad. So it's up here, isn't it? See how quick I can fix that up if I make a mistake? And then, there we go. There's that. It's saying it's only for x is less than 1. So it's only this component. Draw your y equals to x. And start doing your inverse. All right, inverse. When x is 1, y is half. That means now when y is 1, x is a half. Right? Everything changes. So something like that. And then it's going to go through 0. No, that doesn't look right. Okay, try these inverses. Okay. Why doesn't it look right to me? Give me a second. Does that look right? This one's been definitely flipped there. I guess so. Yeah, I guess so. The way I would usually do it is I would draw this green line in maybe text or something like that. I would bend my paper about this line, about this dotted line. And then whatever the imprint is, now I know the answer. In my booklet, I would exactly copy that answer out. So on spare paper, I would do that, create the imprint, but it looks like it'll be something like that when you bend your paper about this. It might not be exactly, look, the reason why it's a little bit higher is because my scale is just a little bit off. That's 1, whereas 1 looks like 1 centimeter. My 1 here looks like it's 2 centimeters long. So that's why it looks a little bit off, but it usually would have been a bit more symmetrical in nature. I think I'm happy with that. We'll see if it's wrong once we do our double I, which is what I was trying to say. I usually don't do I because I like to see what the equation is for double I, and then I'll know if the answer makes sense of what I've drawn. If you know your graphs. All right, double I. Find an expression for inverse. You guys should be able to start that. Just change your y for x and your x for y. Yeah, this program's not responding very well today. Yeah. You gonna respond or not? Probably not. Let's just close it. And the file's too large. 71 pages with all of the things being photos. I think it's just a bit too large for the programs to handle. It seems like. Because even this is crashing it. Come on. God. There it is. Please. Make x a subject. I'll make y the subject. So change your x for y's, double I. X equals y minus half y squared. Can someone, I guess, help us out? What are we eventually going to need to do?
We're going to need to complete the square one.
Yes, I was going to say if you have studied, you would know that has to be a complete to square. Times by everything by 2. 2x. Maybe bring everything to one side as well. 2x equals 2y minus y squared. Bring everything to one side. Y squared minus 2y plus 2x equals 0. Complete the square now. Can you complete the square? To complete the square, we always take our constants onto the other side. Oh, God. All right. This program's gonna not work for us today. I'll just wait for it to close. I'll open it up only to write things on. I'll just use this side of the screen. This one. Should be fine. So, where are we? What did I have? I had y, sorry, for my inverse, we have x equals y minus half y squared times everything by 2. Then we had, bring everything to one side, so y squared minus 2y plus 2x equals 0. What do we do at this stage if we're going to complete the square? Bracket y minus 1 squared equals negative 2x plus 1. You have to take your constant, your 2x is technically a constant now, to your right hand side because you're solving for y. Y is your variable. And then we're going to have y minus 1 squared equals plus minus square root of negative 2x plus 1, and then y equals to, oops, no square term anymore. What is happening? Looks like I really shut this whole thing down. Y equals 1 plus minus square root 1 minus 2x. Which one do I go for? The plus or the minus? Does someone know how to work out now? Am I going to go for the plus or the minus? Because you've got to pick one. You can't have both. Well, what do we know here? We know the domain is x is less than or equal to 1. Sorry, domain is x is less than or equal to 1 for the f of x. That means for your inverse, what does it mean about your range? Isn't y is less than or equal to 1? Don't you change your domain and ranges? So if y is going to be smaller than 1, can you choose the plus? You can't choose plus because 1 plus a number is only going to get larger. So it's obviously going to be 1 minus root 1 minus 2x. And then the last bit, triple I is pretty easy. It just says evaluate 3 on 8. So you're just going to sub in x is 3 on 8. That's the easiest 1 mark you're going to get. But let's see if our graph was right. So I'll just do triple I. Any questions about with completing the square? Any questions? No? Let's see if we can graph this one without the inverse. Okay, to graph that, y equals 1 minus root 1 minus 2x. Okay, take one step at a time, right? First you would draw y equals root 1 minus 2x. Think of it like that. It's better. Because you know what the negative does. The negative just flips it. You know what plusing 1 does. It moves it up 1. So just think of the original, this one here. When x is 0, you get y equals to 1. When x is 0, you get y equals to 1. When y is 0, you get x equals to a half. So when y is 0, x equals to a half. Oh, maybe our graph was wrong. Oh, but we're negative. Hold on. That's just the original. Okay, and then obviously we understand that this is gonna do something like this. Now, you're not going to get negatives because y can never be a negative. So you know your range, y has to be greater than or equal to 0. And as x is larger, as x is, well, what's your domain as well? Your domain is also x is less than half. Because if x was like even 1, 1 take away 2 is negative, which means you know it's not lower. So it's going to look like that. Make it into a negative now. How would you draw the negative? Flip it down. So it'll look like that. Now it's looking like a sideways parabola, which is what it should have been if it was plus minus. Right? Because it's y squared, technically. And then, what do you do if you're going to shift this whole thing up 1? Everything goes up by 1. Right, and that's when if you guys remember, or if you have it on, you'll have it on video. We said x was half, y was 1, right up here, and then pretty much instead of it cutting at -1, it's going to cut at 0, which is what I did as well, and then like this. Pretty much what we had. And exactly the same as what we had originally, which was something like this, and then we had the parabola, which looked like. It was sad, wasn't it? Something like this. And then it went up. Went like that. There. And that was a half, and that was at 1. So, if you can't get the black to the red, you can always do it this way, which is a lot longer. And if you can't do it that way, then I did say, draw your black line, your original one in Texta, and then fold your paper about that dotted line, and then get the imprint, whatever the imprint is, draw it on your paper. Okay? Any questions? All right. I'm going to try to get my other laptop opened up. While we do that, there you go, there's 3D Trig in extension 1, which it was always in. I'll leave that with you guys, and I'll just get the other laptop opened up so we don't have this problem, hopefully.